Welcome to all of you. In this lecture, let us understand the realization of half adder and the half subtractor using multisim. First, let us go through the half adder circuit as well as its truth table. So this was the truth table for the half adder. So two inputs A and B and the outputs are sum as well as the carry. If the input is 0, 0, after a binary addition we are going to get sum is equal to 0 and carry is equal to 0. If it is 0, 1 input, output is sum is 1 and carry is 0. Input is 1 and 0, sum is 1 and carry is 0. If inputs are 1 and 1, sum is 0 and carry is 1. Now placing this on the K-map, we are going to have the solution for that. So this is the K-map for sum. So we are going to get A XORed with B. This is the K-map for the carry. By this we are going to get C is equal to AB. Now this for the corresponding circuit as per these expressions. So directly basic gates are being used over here. So similarly we are going to have the same for the half subtractor. Now this is for the half subtractor. So this is for the truth table. So here the outputs are going to be the difference as well as the borrow. The inputs A and B. So input 0, 0, output is 0, 0, input is 0, 1, subtraction is being done. So difference is 1, borrow is 1. If it is 1, 0, difference is 1, borrow is 0. If both are 1, 1, output both are 0 and 0. Mapping this onto the K-map, we are going to have the expression for difference, it is A XOR B, and for borrow, it is A dash B we are going to get. Now realizing these two expressions on by using the basic gates, we are going to get this representation. Now let us realize both half adder as well as the half subtractor by using multisim. At first, let us realize the half adder. Let us start with the multisim. For the reference of a half adder, the expression has been noted here, the sum as well as for the carry. Now let us start with the rigging up of the circuit. So what we require is one XOR gate as well as one AND gate. So let us first take those two gates. So we need 74LS and then XOR gate, we know the number, so you can have direct selection number over here. So here we are going to have the XOR gate, so select it, then only one XOR gate is sufficient for us, so place it over here. Then we need to have AND gate selection, AND gate number I can type over here. So I'm going to select two input AND gate. So place the AND gate over here. Then we need to have the inputs, two inputs we require. So let us consider the digital sources for that. So digital sources, interactive digital constant. So two we require. So let us place one over here and let us place one more over here parallel to that, right? So two are sufficient. Then what else we need is, so in order to observe the output we need to have probes, or we can also make use of the LEDs. So let us select probes for that. So in the probe I will be selecting the red color, so probe red, you can select any of these colors available. Okay, so first probe I will be placing at the output of the XOR gate directly, and one more I will be placing at the output of the carry, that is over here, output of the AND gate. So that's all we require. Let us close this panel. Now make a connection with respect to the inputs. So for inputs I will be placing the connection. Then one more connection here. right? So sum is realized, sum is equal to A XOR B. So this is one input, this is another input, so that will be A XOR B. Now the carry has to be realized, that is equal to A and B. So now let us share these values, the input over here. So this is for the first one A, and this one more will go to, let us take that to the B, right? So now for the sake of realization, so I can keep it over here, keep it over here. Let me designate this as input A. Okay, so just double click on this, new window will open. So there I can designate it as one more input B, right? So inputs are A and B. So if you want here, you can make it as, this is sum, you can write it as yes, or completely let us make it as sum, right? So here it is the carry, so carry out, or you can just say it as carry. Fine. So both of these two have been realized, the sum as well as the carry. Now let us run the simulation for this one. So while simulating, so just note down inputs are equal to 0. Now I will be starting the simulation. So simulation I am running. So now I need to verify the truth table. So to the possible extent, let me take the truth table over here. So truth table, this is what I require. So let me copy this and try to place it over here, right? So better to verify now. Okay, so I have already entered into the simulation mode. Now input is 0 0, the first case, output is 0 0. So these probes are turned off. Now input is 0 and 1, sum is 1, carry is 0, sum is 1, carry is 0. Then 1 0 I'll be making, again sum is equal to 0, carry, sum is equal to 1, carry is equal to 0. I'll make both of these as 1, so sum is 0 and carry is 1, right? The truth table now is being verified. So let us make a small change over here and we can proceed with the half subtractor, right? So let me stop this simulation and I will just take out this table so that I need to proceed with the half subtractor. So I'll just delete this one, so I don't need this also. Carry, this difference remains the same, whereas this is going to be changed. So you can just verify it over here. So I can just simply place it over here for your reference, right? And then the difference, the borrow expression, let me see, does it copies to this position or not? Okay, this is working good. So I'll place over here. Okay, fine. So what else we require with respect to the existing expression? Let us make a verification. Okay, so difference, it is A XOR B, right? So there will be no change with respect to this one, whereas the borrow is going to be, it is A dash B. So that means for this we have to put a NOT gate over here. So let us place a NOT gate over here. So first eliminate this, then I need to place a NOT gate, right? So say okay. So one NOT gate is enough for us, and this one is this. Okay, so this is in this direction. I need to place this in a vertical position, so I need to rotate this. Just simply press Ctrl R. Use Ctrl R for rotating. Now it has got rotated. Fine. So we can directly connect it over here and then extend this to A. Right, so job done. Right, so now I need to verify the truth table. The sum as well as the borrow circuit is completed. Now verify the truth table with respect to the half subtractor. Okay, the names are going to change, so let us change that also over here. So this is difference, and this one borrow, right? Fine, so let us make the verification of the truth table. Start simulation, run. Now 0 0, output is also 0, we are getting that. Then 0 1, output is 1 and 1, right? Then 1 0, output is 1 0, fine, both are 1 and 1, output is 0 and 0, right? Now the truth table has been verified. The same can also be done by making use of the NAND gates also. So this is what the verification of the half adder as well as this particular the half subtractor. Thanks for joining.